Okay, I had to make a new review because the sound wasn't working, and we figured that out, and I finally was able to fix it. So this is going to be part one, and I'll hopefully get all the parts in by the end of the day, okay? All right, so on numbers 1 and 2 it says, for each problem, simplify each expression, name each polynomial by degree and number of terms, and identify the end behavior and write the answer in limit form. Don't have to worry about the limit, but we will have to write the end behavior. Okay. So the first thing I want to do is combine like terms. Well, the fact that this is a plus sign means that I just need to combine the like terms right here. I've got 8n cubed and 4n cubed. The highest power is 3, so let's add those. 12n cubed. Okay. I've got 5n squared plus 6n squared, and that's 11n squared. Okay, and then I've got negative 8, and I've got a positive 4. Add those, and I've got 12. Oh, just kidding. So negative 8, which means it is a negative 4. My bad. Okay, so minus 4. Now, as far as naming it, there are some things you have to remember. The degrees, if the degree is 0, then it is a constant. If it's just a number. Okay, so if it's a degree of 1, so it's got x, then this one's no x. This is just x to the first. That's linear. If it's 2x squared, then that's quadratic. If it's 3x cubed, then that's cubic. If it's 4x to the fourth, that's quartic. 5x to the fifth, that's quintic. And anything higher is just a polynomial of degree, whatever. Okay? And then number of terms, there's only three things you need to worry about. 1, 2, and 3. So if it's got 4, it's just polynomial with 4 terms. But if it's 1, then it's a monomial. If it's 2, it's a binomial. And if it's 3, it's a trinomial. So I have to write cubic. And then 4, polynomial with 4 terms or so, or anything higher. Okay. Well, this has a power, the highest power is 3, so it's a cubic. There's 3 terms, so it's a trinomial. Okay? And so that names it. And so the other thing it says is the end behavior. So let's go over end behavior again. I know I went over in class, but we'll go ahead and go over it. If the degree of your function is even, meaning the highest power is even, okay? Or if it's in multiplied form, then if the multiplicities add up to an even number. You have some options. Even functions go in the same direction. They either go up and up, so both positive infinity, or they go down and down, negative infinity. And what that depends on is the leading coefficient, and that's the number in the front. So the leading coefficient, or the LC. So every time I write LC, I'm referring to the leading coefficient, okay? So if the leading coefficient is positive, then they go up, up. If the leading coefficient is negative, then they go down, down. If the degree is odd, then you have 2 options. Evens go in the same direction, odds go in opposite. Well, in opposite directions, that means 1 down, 1 up, 1 up, 1 down. Well, in general, you might notice that this function starts from below, because we read left to right, goes below and goes up. Well, that's because the leading coefficient is positive. If it starts from above and goes down, then the leading coefficient is negative. Okay, so that's starts off with negative and then goes to positive. Starts with positive and then goes to negative. So you have to remember, left to right is how we read these, from the left to the right. Okay? Alright, so looking at my problem, I've got a power of 3 is the highest degree. That means it's an odd function. The leading coefficient is the number in front of that, which is a 12, which is positive. So I'm dealing with this. I will give you this. As x approaches negative infinity, y approaches. As x goes to positive infinity, y approaches. And your job is to answer what those limits are. Okay, what the function's approaching. So, if it's going to negative infinity, or if it's an odd positive, then it starts off at negative infinity and goes up to positive infinity, and there's your answer. Okay? So let's do number 2. On number 2, we've got this minus sign in between them, which is a little bit more work. What you have to remember to do is minus everything. The easiest thing to do is to go ahead and rewrite your expression. But in the second part, let's go ahead and distribute that minus sign. So I've got minus 5n to the fourth plus 7n cubed and minus 8n squared, and then we're going to combine like terms. So 4 is the highest power, 3 into the fourth, and negative 5 into the fourth is negative 2 into the fourth. Negative 7n cubed and positive 7n cubed cancel each other out. Positive 8n squared and negative 8n squared cancel each other out, and I'm left with this term right here. Now as far as naming it, the highest power is a 4, the only power is a 4, which makes it a quartic. And there's only one term, and if it's one term, then it's a monomial. So it's a quartic monomial. Now the only other thing we need to do is talk about end behavior. Okay, so as you go to the left and the right, where's the function going? Well, it's an even function with a negative leading coefficient. An even function with a negative leading coefficient, they both go down. Oop, I didn't put a negative on that one. They both go down, so they're both negative infinity. And there you go. That's your answer for that part. Okay, let's move on to number 3. Identify the end behavior. So this is just focusing on end behavior. So what's the degree? Well, the degree is 5, which is odd, and the leading coefficient is the number in front of the term with the highest power. So the leading coefficient is a negative. So if I've got a negative odd, well, odds go in opposite, so it's either this one or this one. Well, this one goes up, this one goes down. Since it's negative, it goes down, which means positive and then negative. So as x goes to negative infinity, y goes 2. As x goes to positive infinity, y goes 2. On the left, you got positive. On the right, you got negative. And there's your answer. Okay. Number 4, it says the same thing. What's the degree? The degree is the highest power, which is 4. Okay, so it's an even. And it's a negative number in front of it, which is a leading coefficient is negative. So it's pretty much the same as this one, even with negative leading coefficient. So the answer is the same as that right there. Okay, so that is also the answer to number 4. Okay, let's move on to number 5. On number 5, it says, given this function, it says, find the zeros and state the multiplicities, degree, sign a leading coefficient, and function in factor form. So let's talk about multiplicities for a second. If you think about the function y equals x, it's a linear function, and it just crosses through the x-axis. It should cross at the origin, but whatever. I'm never going to get it through there. Okay. But it just crosses straight through. If you think about y equals x squared, at 0, 0 squared is 0, but it has this u shape, which means it bounces off the x-axis. And then if you think about y equals x cubed kind of does this wave through. So even though it does cross like the power of 1, it crosses the wave. And those are the only 3 that we have to really worry about. So if I'm looking at this, I'm looking at my 0. So I've got negative 4, negative 2, 0, and 3, right? So for part A, I've got negative 4, and it crosses straight through, so I'm going to say multiplicity is 1. Negative 2, it bounces, so I'm going to say multiplicity is 2. 0, multiplicity is 1 because it crosses straight through. And 3, multiplicity of 3 because it crosses the wave. Okay, the degree. Add up the multiplicities, because if you multiplied all these out, the highest term would have all of those degrees. So add up all the multiplicities. I'm pretty sure I just butchered the spelling of that, but whatever. Okay. 1, 2, 3, 4 plus 3 is 7. So the degree is 7. That's an odd function, which I knew because they went in opposite directions. See how it started below and ended up there? Okay, so it was an odd function already. If they were both up, I would say even. If they were both down, I would say even. If they're in opposite directions, it's got to be odd. 7 matches that. Sign a leading coefficient. Well, the fact that it starts down and goes up, meaning starts down and goes up, that's in general going up, which means a positive leading coefficient. So the last part is write the function in factor form. So if I want to write the function in factor form, then I need to write out my factors. This is a negative 4 as my 0, which means it's x plus 4 in my factors. So multiplicity of 1, so I'm going to put a 1. I don't have to, but if you want to, it's fine. Negative 2, so x plus 2. Remember, it's a 0. What makes this equal 0? Multiplicity is 2, so put a 2. 0. I don't write x minus 0. So I'm just going to write x, and I'm going to put it in the front. Power of 1. And then 3, so it's a positive 3, so x minus 3, power of 3, because of multiplicity. And there's your answer with part D. Okay. So that's all of part of number 5. Let's go to number 6. It says factor each expression to find all zeros. Well, the first thing you want to do when factoring is think about, is there anything that I can factor out, any common factors? And I notice that this says x to the 4th, x cubed, and x squared, which means they all have at least 2 x's. So I'm going to factor that out first. And I'm left with 5x squared plus 24x minus 5. Okay, and I want to know when this equals 0. Well, if you're multiplying two things and it equals 0, what you can say is, well, let's solve each of them individually. When does x squared equal 0? And then when does 5x squared plus 24x minus 5 equal 0? X squared equals 0 when x equals 0, because if you take the square root of both sides, you get 0, and it's multiplicity of 2. I don't have to worry about that, but writing the M2, you do have to write x equals 0. But it kind of helps me determine if I'm done, because it says a power of 4, which means I should have 4 answers. I'm going to have 2 right here because of multiplicity of 2, and then I should have 2 right here because it's a quadratic. So at this point, what I want to do is I want to try and factor this. If I can't, then I'll use the quadratic formula. So first I'm going to multiply 5 and negative 5. So that's negative 25. And I want to find the factors of negative 25 that add up to 24, the middle term. So if I think about 1 and 25, the only way that I get a negative when I multiply is if one of them is negative, but I got to have a 24 when I add, which means 25 needs to be the positive one. Okay? So I'm going to write x minus 1 and x plus 25, but do not forget that because I multiply the 5 back here to get that, I have to now divide by that 5. Okay? So because of that, I multiplied, I have to divide by it. Okay, so this is still just x minus 1/5, because all I'm doing is solving. I'm not writing in factored form. And then this is x plus 5. Because 25 divided by 5 is 5. Equals 0. So what makes this equal 0? Well, the opposite of a negative 1/5 is a positive 1/5, and the opposite of positive 5 is negative 5. So do I have 4 answers? Because the power of 4, 1, 2, 3, 4. So I'm good. Between this and that, there's my answer. Or my answers. Okay. Let's move on to number 7. Find the function in standard form that has the following zeros. Well, if negative 2 has a multiplicity of 2, that means some people like to go ahead and start with x plus 2, and they know to put a square there. I'm going to go ahead, since I know I need to multiply it out, I'm going to write x plus 2 twice. Okay? If it's a negative 1/2, then I would say x plus 1/2, so the opposite sign. But bottoms up means I'm going to bring the 2 to the front and say 2x plus 1. And then the fact that I have a 0 just means x minus 0 or x, and so I'll just put that in the front. Alright, now I want to multiply everything out. Okay, so I'm going to multiply these two out first. X times 2x is 2x squared. X times 1 is x. 2 times 2x is 4x. 2 times 1 is 2. I'm going to combine like terms. 2x squared plus 5x plus 2 times x plus 2 times x. So I'm just bringing that down. I'm bringing that down. And now I'm going to distribute this x plus 2. X times 2x squared is 2x cubed. X times 5x is 5x squared. X times 2 is 2x. 2 times 2x squared is 4x squared. 2 times 5x is 10x. And 2 times 2 is 4. So, here's what I've got. I've got x times 2x cubed plus 9x squared plus 12x plus 4. So last step is going to be to distribute my x. So I've got x times 2x cubed, which is 2x to the 4th. X times 9x squared is 9x cubed. X times 12x is 12x squared. And x times 4 is 4x. Oh, I wasn't writing it to where you could see it. And there you go. Okay? So when it says find the function in standard form, remember this is factored form, and that's standard form. Okay, let's do some division. We multiplied polynomials, now let's divide some. Okay. If I'm dividing by a binomial and it says x minus 8, well, what you have to remember with synthetic division is so that we can add instead of having to subtract every time like you have to do in long division. We'd make this equals 0, and then we solve. So x equals 8, and that is what goes inside there. Now across the top, you guys are pretty good about, you just know it's the numbers in the front. So 6, negative 50, 14, 23. Things to make sure of: are they in standard form? Is everything in order? And are you missing any terms? And we're not, so we're good. Okay. First, I'm going to bring down the 6. Okay, and then I'll multiply. 8 times 6 is 48. Negative 50 and 48 is a negative 2. 8 times negative 2 is negative 16. That is again a negative 2. 8 times negative 2 is negative 16, and that is 7. Okay? Sometimes people like to quit right here, but you're missing the last point or two if you stop right here, because you're not actually done. All you've done is the process. You haven't told me what the actual answer is. So the answer is, if I start with a power of 3 and I divide out this, I'm left with this quadratic: 6x squared minus 2x minus 2, power of 3, so this is a power of 2, and then plus your remainder divided by what you divided by, x minus 8, and that is your final answer. Okay, now let's talk about number 9. On number 9, it says divide by x plus 4, so if I set that equal to 0, x equals negative 4. So I'm going to put negative 4 inside the half box. But what I have to notice right here is that I've got x cubed, I've got x squared, but I don't have an x term. So I'm going to have to add a plus 0x in there. Okay, so I've got 1 for that one, 6, 0, and negative 42. Okay. Bring down the 1. Negative 4 times 1 is negative 4. That's a positive 2. Negative 4 times 2 is negative 8. That's a negative 8 as well. Negative 4 times negative 8 is a positive 32. And I'm left with a negative 10. Okay? So final answer, I started with a power of 3, then I end up with a power of 2. X squared plus 2x minus 8 minus 10 divided by what I divided by, x plus 4. And that is your final answer. Okay? Let's do number 10. Okay, Pascal's triangle. Now, if you don't remember Pascal's triangle, you are going to have to create it on the test. So, just as a little reminder, Pascal's triangle, we start with a 1, and then we do a 1 and a 1, and then we do 1, add the 1 and the 1, you get 2 in between them, and then put another 1. 1, add the 1 and 2, get 3, 2 and 1, get 3, 1 more, 1. 1, add 1 and 3, get 4, 3 plus 3 is 6, 3 plus 1 is 4, 1. 1 plus 4 is 5, 10, 10, 5, 1, and you could keep on going as long as you needed to. If you needed 6, 1, 5 plus 1 is 6, that's 15, that's 20, that's 15, that's 6, and that's 1. Okay? Now this says x plus 3 to the 5th power, so if you're thinking 5th row, 1, 2, 3, 4, 5, you'd be using that one, but it'd be wrong. This is actually when it has a plus b to the 0 power, so 0 and then this is 1, because a plus b to the first is just a plus b, 1a plus 1b, 1a plus 1b. Okay, so when you're looking for the 5th power, use the one that has the 5 in it, this one right here. 1, 5, 10, 10, 5, 1. So I'm going to write those numbers out. 1, 5, 10, 10, 5, and 1. Okay, so now what I do is I take the first term, x, and I raise it to the 5th power and write it for the first term. So I've got x to the 5th first, and then go down in power. X to the 4th, x cubed, x squared, x. Okay, the second term, the 3, I start with the power of 5 here. 3 to the 5th, and then go backwards. 3 to the 4th, 3 to the 3rd, 3 squared, 3 to the 1st, and then no 3. Okay, now these are all, this is a plus sign, so they're all plus. So now all I need to do is simplify these expressions. Okay? Alright, so I've got 1x to the 5th, that's just x to the 5th. I've got 5 times x to the 4th times 3 to the 1st. 5 times 3 is 15, and then x to the 4th. 3 squared is 9. 9 times 10 is 90, so I've got plus 90x cubed. 3 cubed is 27. 27 times 10 is 270 x squared. 3 to the fourth is 81. 5 times 81 is 405. So I've got 405x to the first. And then 3 to the fifth is 243 times 1, so it's just 243. So this is my answer. Now, I could have gotten it by multiplying x plus 3 out by itself, or out times itself 5 times. But that would be a lot of time and a lot of multiplication, a lot of room for error. So, it's easier if you just remember Pascal's triangle. Okay. State the possible rational zeros for each function, or for this function. So, the first thing I want to do is just make sure you remember the process. What you have to do is you have to divide the factors of the constant, and the constant is the number without an x, divided by the factors of the leading coefficient, which is the number in the front of the term with the highest power. Okay? Factors are the things that multiply to give you that number. So what multiplies to give me 15? 1 and 15, 3 and 5. So what multiplies to give me 4? 1 and 4, 2 and 2. But I don't need to write down 2 twice. Okay, I'm not done yet because what I actually have to do is divide everything. So plus and minus. 1 divided by everything, 3 divided by everything, 5 divided by everything, and 15. Now, the thing about it is that with the exception of 1, well, you can say 1 is odd. These are all odd, and then 2 and 4 are even, so these numbers are not going to simplify. And if they do simplify, remember you don't have to write it down twice. So 1 divided by 1, 1 divided by 2, 1 divided by 4. 1 divided by 1, 1/2, 1/4. Now 3. 3, 1/2. 3 divided by 1, 3 divided by 2, 3 divided by 4. 3 divided by 1 is 3, 3 halves, 3 fourths. Same with 5. 5, 5 halves, 5 fourths. Same with 15. 15, 15 halves, and 15 fourths. And then I'm done. Okay? So it's just stating your possible rational zeros. Okay. Using the given roots in synthetic division, find all roots and write the function in factor form. So, they gave me this one root, and what I want to do is I want to divide it out and solve the remaining function. Okay. So first I want to do synthetic division with negative 5 halves. So I'm going to do 10, 43, 53, and 20. If you get a number like this in a problem, and it's a fraction, chances are it's going to simplify really easily. Or don't forget you always have a calculator if you're unsure and dealing with that. So I've got negative 5 halves times 10. Easiest way to think of this to me is just divide 10 by 2 and I get 5, and then multiply those and I get negative 25. 43 minus 25 is 18, and negative 5 halves times 18 is just 18 divided by 2, which is 9, times 5, which is negative 45. Okay? 53 minus 45 is 8, so again, negative 5 halves times 8, 8 divided by 2 is 4, and that is negative 20, and I get 0. In a problem like this, when I say given a root to find the rest, if you don't get 0, that means something is wrong, because you should get 0. Okay, so what I want to do is find all the roots, which means I need to factor this left over. That's a power of 3, so this is a power of 2. Okay, so I could either use quadratic formula, or I could factor. If you want to use quadratic formula, don't forget it's negative b plus or minus square root of b squared minus 4ac all over 2a. Or you can factor it. 10 times 8 is 80. The factors of 80 that add up to 18 are 8 and 10. So I've got x plus 8, x plus 10. But do not forget, because you divided by that number, you have to, or because you multiplied by 10 in the beginning, right here, you have to divide by 10. So this simplifies to x plus 4 over 5, because they're both even, and x plus 1. So what does x equal? The opposite of positive 4/5, which is negative 4/5, and the opposite of positive 1, which is negative 1. And there you go. Okay. So let's move on to 13. It says determine the function in standard form with the following zeros, which means I want the function in standard form. Right now all I got is zeros, so the idea is going to be to go from zeros to factored form to standard form. Okay, I have 3 zeros in front of me, but because one of them is imaginary and the other one is, and another one is irrational, I know I've actually got 5 zeros. If you've got a positive 3i, you also have a negative 3i, and if you've got a positive square root of 5, you also have a negative square root of 5. So what I want to do is I'm going to write this out in factored form, and then multiply it out. Okay, so I'm going to write down x for this one, x minus 3i for that one, and x plus 3i, because I want to keep those together. And then x minus the square root of 5, and then x plus the square root of 5. And now I want to multiply it out. So I'm going to multiply these two out first. X times x is x squared. X times a positive square root of 5. X times a negative square root of 5. And then negative square root of 5 times positive square root of 5. Negative square root of 5 times positive square root of 5 is a negative square root of 25, which is just negative 5. Anytime you multiply square root times itself, it's just the number on the inside. Anytime you multiply conjugate pairs, which means they're the same thing, the opposite signs, the middle terms will always cancel out. This is x squared minus 5. Okay. Now this one. Again, these are conjugate pairs. The middle terms will cancel out, but I'll prove it. X times x is x squared. X times 3i is 3ix. Negative 3i times x is negative 3ix. And then negative 3i times positive 3i. Negative 3i times positive 3i. That's a negative 9. I times I is I squared. And I squared, I don't know if you remember, I is the square root of negative 1. So if I square it, I squared is negative 1. If you need to, tap it in your calculator. I squared is on your calculator above the decimal, or I is, and if you square it, you get negative 1. So this is negative 9 times negative 1, and that's positive 9. So plus 9. So I've got x squared plus 9, and then bring down the x. Okay? Now I'm going to distribute these two, and then I'll distribute my x as my final step. X squared times x squared is x to the 4th. X squared times negative 5 is negative 5x squared. 9 times x squared is 9x squared, and 9 times negative 5 is negative 45. So that's x to the 4th plus 4x squared minus 45, all times x. Distribute my x, and I'm left with x to the 5th plus 4x cubed minus 45x, and that is my final answer. Power of 5, 5 zeros, matches up. Okay, let's go to 14. So on 14, the question is, in dealing with the numbers, you say, okay, is there a square root of 72, and if not, what perfect square goes into it? And when dealing with the powers, the variables, you gotta ask, how many times does this root, this understood 2, go into these numbers, and how many are left over? Okay? If I look at my perfect squares, as far as 72 goes, you always want to start from the highest. 72 is less than 81. So if I think about my perfect squares, I've got, let's go with 8 squared. 8 squared is 64. 64 does not go into 72. 7 squared is 49. 49 does not go into 72. 6 squared is 36. 36 does go into 72, and it goes into it twice. You always want to check these before you start checking these. Because some of you would get here and say, okay, oh, 9 goes into it. Or you might say 4. If you split it up, you know, some people see 8 and 9 first, and they're like, oh, 9 is a perfect square root, so I can take the square root. But 8 has a factor of 3. And if you divide by 4, let's see, it's 8 times 9, so 4 times 18. You get 4 and 18, well, 18 divides by 9, so you're not done. You want to find the largest perfect square that goes into it, and that's 36. Okay? So this is 36 times 2, So the square root of 36 is 6, so 6 goes on the outside, but 2, there isn't a square root, so we leave the 2 on the inside. Okay. Now I ask myself, how many times does 2 go into 2? And it goes into it once, with no remaining. How many times does 2 go into 5? 2 times 2 is 4, and then I've got 1 remaining. How many times does 2 go into 3? It goes into it once, with 1 remaining. And that is my final answer. Okay. Last question for part 1 is 15. It says the fourth root of 324, and then all those variables. If you look at your power chart, when you're looking for powers of 4, you look across here, and 324 is in between those two. So what I need to do is see if any of these 3 numbers go into it. 256 does not go into 324, it's too big. But 81 actually does. 81 is 324 times 4. So if I divided that in my calculator just to check, I would say 324 divided by 81, 324 divided by 16 until I find the one that does. So this is 81 times 4. I don't care about the 4 because I don't have the fourth root of a 4. But I know the fourth root of 81 is 3. So I've got 3 right here, and then in the fourth root I've got this 4. Okay? So that one comes out, that one stays in. Okay, now then I ask myself, how many times is 4 going to 13? 4 times 3 is 12, so 3 times. 12, so 1 remaining. 4 times 1 is 4, 6 has 2 remaining. 4 times, well, how much is 4 going to 18? 4 times 4 is 16, and 18 minus 16 is 2, so I've got 2 remaining. And there's my answer. Okay, so that's part 1, and then we'll pick up on 16 in part 2.